And hello again. So this is a quick overview of homeworks for the so-called week 1-2, and that is everything that is about chapter 3. Okay, so we have a few things here. One is discussion. Feel free to click, participate, and I'm not gonna say much. The second thing I advise you to do is a quiz. As I was saying in the introductory video, a quiz can be repeated as many times as you want to. The idea is to give you another excuse to look back at this week's materials and uh, check yourself how well do you understand these concepts. So if you have, after the first attempt of the quiz, if you want to look back at something or look in the book, that is wonderful. All right, so a new type of discussion here, be a Python, based on chapter 3. If you open it, you will see a bunch of different questions and in general some comments on how to do them. So read this carefully, which is rule of thumb for every story problem of any kind. Read it 1, 2, 3 times so that you understand it. And first of all, if you are the first person to address, say, problem number 0, you can just make a comment about it, and you will need to express in few sentences what this does. And if you express it fully, that's good enough. If you explain fully what this code does, that is good enough for all practical purposes. You get full credit. Now, if you are not the first person who will comment on this question, you can make a comment to some and add to someone else's explanation if you feel that this explanation is insufficient, or describe it in other words or in better terms, like use all this terminology about the Boolean expression and about the what kind of decision structure this is. And in any case, after a couple of comments or a few comments, probably this would be done, and I can just comment saying that this was explained sufficiently and be done. In any case, before you comment on something, make sure you read at least the previous comments on the same problem, so that you don't repeat the same stuff over and over again. Other problems may or may not look to you a little bit more complicated, and based on the lecture, you should be able to answer these questions and discuss them in detail and compare, for example, these two code snippets. Ideally, you should be able to do that without actually typing this up and writing this code. I'm looking forward for you slowly processing this, thinking through this, rather than just typing it up and seeing exactly what it does. You can always check yourself, but it's important to explain it to yourself and to kind of understand every bit of this code, what it does exactly. And that is really the, I see that somebody already made a comment. That is really the point of this discussion. So I want you to kind of work through this intellectually and dissect it sufficiently so that you don't feel that this is just some magic symbol combination that works, or this is magic symbol combination that is magic words that do something. So understand every bit of it, understand what is indented, what is not indented, why they are indented differently. If you are out of comments in terms of improving on any of the discussion on any of these problems, or you feel that those problems were sufficiently picked on, you may start doing something else or something similar to one of these examples and describing it, but please only do so if you see absolutely no opportunity to add to any of these problems or discuss any of these problems. If you have any questions about this chapter, feel free to discuss them as well. If you had a question, you thought about it, that may be a good place or good thing to discuss, especially if it somehow relates to one of these examples. For general discussions, though, about the chapter material, use the other discussion assignment. I hope you have fun with this assignment. Usually I do it in class, in person, so I just write on the board a few of examples like that, and I'm waiting for students to talk about them and suggest what they actually do, or maybe I even, not in this case, but sometimes I write examples with mistakes to ask them what those mistakes are. So this is our discussion, and some other discussions may have a requirement for a comment and for a solution and then a comment on someone else's solution. This one, just do one of the two. Okay? All right, and going back to chapter 3, now we have a game of numbers. This is probably the most difficult part of the whole chapter, and probably the most difficult one of all the assignments some students have a difficult time with this assignment. Let's put it like this. Okay, I don't think it's even close to the most difficult assignment for this class, but maybe for a beginner it may look very intimidating. There is a description what needs to be done. Again, read it 3 times so that you at least know what it is saying about. And this thing about divisible and not divisible, it's really about the use of remainder. And the idea there is that it's divisible when remainder is 0. And how do you do problem solving? You have a problem with a lot of requirements. You can, first of all, see how it's supposed to work. I wrote this program, I ran it a few times, and this is the output. And also, you can look at the hint. This is really a big hint here, describing what kind of things you need. The most interesting part is making if, elif, else statement to work, and also using integer and remainder operators. And finally, a hint, simplify. So one of the problem-solving skills, if you are facing a sophisticated problem, simplify it a little bit so that it still captures some of the original problem's issues and properties, but is easier to do. So for a partial credit, you can just do what the hint describes, and that is really cool already. Now, to remind you what is divisibility and how it works, divisibility and remainders. So if I have a number 50, I can divide it by 7. Let me do a print statement here. Print. First of all, I'll do this in a string to explain what it is, and then it's equal to the value, comma, the actual value. Integer what is integer division is when you divide with remainder, or in other words, you do long division. All right, let me resize this. So integer division, 50 divided by 7 equals to 7. If you remember integer division or remember how to do long division, when you do long division, 50 divided by 7 equals to 7. And also there is a remainder. How to find the remainder? Let me do another printing statement. Remainder, well, okay, I'll add the word quotient. And here remainder means percentage sign, and in Python, sorry, percentage sign means remainder. So just to finish with this example real quick, I will print this means that 50 is equal to 7 times 7, which is 49, plus 1, and 1 is the remainder. The quotient and the divisor was 7 in this particular case. Let me close everything we don't need. And sorry, I also planned to close idle. Okay, run. So integer division quotient 7, integer division remainder 1. What this means is that 50 divided by 7 equals to 7. 7 times 7 is 49, plus remainder 1, 50. All right, so that is reminding you again what is remainder. Now, second thing, divisibility. I want to check if the number is divisible by 5. How would I do that? Well, I might want to ask a user to supply an integer number. Then I might want to check if this number is actually divisible. Okay, so the first line will be number equals to int of input an integer and second thing I need to so this will enter a number, sorry, and second, check if the number is divisible by 5. So there should be an if, and there should be your favorite boolean. If something, print number is divisible by 5. I need quotation marks. And the other condition, else, print not divisible by 5. So I gave you time to think what goes in here. All right, so remember basic math, a number is divisible by 5 if the remainder is 0. So for example, 50 is divisible by 5 because 50 divided by 5 is 10 and remainder is 0. And 6 is not divisible by 5 because the quotient would be 1 and remainder would also be 1. Okay, so number remainder divided by 5 equals to what for the number to be divisible? Double equality to check equals to 0. So this is a condition whether or not a number is actually divisible by 5, and the condition says, is the remainder of the division 0? If the remainder is 0, then divisible by 5, if and else not divisible by 5. Okay, So let me run this code. Enter an integer. 14. 14 is not divisible by 5. All right, let me check an error here in spelling, a typo. And let's run this a couple of other times. So enter an integer 10. That should be divisible by 5. 10 is divisible by 5. Okay, let's rerun. 23. 23 is not divisible by 5. So this number %5 means the remainder when divided by number by 5. And in the else case, I can actually print the remainder. So comma, the remainder is not 0. In particular, it's equal to number remainder 5. Okay, so let's rerun it again and see how it works now. So enter an integer 34. 34 is not divisible by 5. The remainder is not 0. Well, okay, it is 4. Run it yet again. Enter an integer 12. 12 is not divisible by 5. The remainder is 2. So yes, I think you are now in good shape to do your homework.